Do you want to go beyond theory and actually deploy machine learning? This is where your real journey begins. This is not just a tutorial, it is your first step towards becoming a production level ML engineer. The first step of machine learning workflow is problem definition. You should understand the problem very clearly. Before jumping into code or data, we must clearly define the business problem we are going to solve. The goal of a problem might be building a machine learning model that predicts the price of a house based on features like location, area, number of bedrooms and bathrooms, and year built. So, in this case study, let's see how we are understanding the problem definition. The machine learning type that we are going to choose is regression because of the reason we are going to predict is price. The target variable is price, which is continuous. The reason why we need to solve this problem is because real estate companies and property platforms use such models to suggest accurate market prices to sellers and buyers. A clear definition helps in choosing the right algorithms, evaluation metrics, and even the data. So, defining the problem very clearly is the first step which you need to do with clarity. Second step, data collection. Once the problem is defined, the next step is gathering relevant data. We can collect data from various sources. For this particular problem statement, we can collect data from public real estate data sets. For example, Kaggle government data. We can collect data from web scraping, from property websites like Magic Bricks, 99 Acres, or Zillow. We can collect data from APIs, from real estate services, or manually curated CSV files. By collecting a data, we can collect the features each and every column. So we need to ensure each and every column is present in all the data set to build a machine learning model that learns properly. So for this particular problem statement, we should make sure these columns are there: location, area, bedrooms, bathrooms, year built, and price. We might face some challenges in data collection. Data might be scattered, inconsistent, or it might contain missing entries. Scrapping or API usage may require handling rate limits or authentication. These are the problems we need to face while collecting the data. Third step is data cleaning and pre-processing. This is the most step of a data scientist, ML engineer, or an AI engineer. In this particular step, we need to spend a lot of time after getting into the field. This step ensures that the data is in a usable and high quality format for modeling. For this particular data set, if you are handling missing value as the first step in data cleaning, let's consider an example. If some houses don't have a recorded year built, we need to fill that particular value, missed value, with average, mean, median, or more. We call them as central tendency, which represents the whole data. That particular value represents the whole data. With particular value, we are going to replace those missing values. Next, data type conversion. We need to ensure that each and every column are filled with numerical values because in this data set, we are going to use regression as a machine learning model. If this particular data set doesn't have numerical values, it will not work. That machine learning model that we are going to choose will not work. So the next step is handling duplicates. We need to remove any duplicate rows. Duplicate rows means if a particular row is repeated more than once, when we call that as duplicate rows. Next step is encoding categorical variables. We need to convert location from text to numbers because as a machine learning model, if we choose regression, it can understand only numbers. It can't understand alphabetical characters. So in this step of encoding, we'll be converting that yes or no or any alphabetical characters into numbers, into zeros, ones, twos, and threes, so that that machine learning model could understand and figure them out the difference. Next step is scaling features. We should normalize area or price using minimum max or standard scalar for models like linear regression, so that that particular data or the data that we have in hand has equal values or normal values in it. Scaling features in data cleaning and pre-processing is considered as one of the important steps in machine learning because it is helpful in improving the model's accuracy, stability, and training efficiency. The major reason behind data cleaning and pre-processing is dirty data can lead to poor model performance or misleading conclusions. This is the step for understanding the data, exploratory data analysis. Here we explore the data to understand its patterns, relationships, and intent insights. These are the techniques we'll generally use to understand the data. First step is univariate analysis. we need to look at each feature individually using histograms, box plots. By creating those visualizations using Python or R, we can understand how each and every column works and how it contributes towards the target column. Second, bivariate analysis. We need to explore the relationship between each and every columns. If any other columns are related other than the target column to find the output easily. The next step of correlation matrix. This is used for understanding the relationship between each and every column, similar to bivariate analysis, but it is created in a way that's completely different from histograms or scatter plots. It is used for identifying how strongly features like area or bedrooms relate to price. Similar to finding null values or missing values and replacing them with mean in data cleaning or data pre-processing, here we'll do outlier detection. In this step, we'll spot and handle extreme values. For example, prices are highest in central city locations. More bedrooms typically mean higher price but with diminishing returns. So, in this step, we can find if a tiny house has some extremely high price. If there is an outlier which says the value is completely wrong from what it should have been, we can replace that value or we can remove that value. Similar to finding a missing value, we are finding the wrong value and treating them. This is called as outlier detection. This whole process of exploratory data analysis is helpful in shaping your feature selection and modeling strategies. In general, target column or dependent column means that is the column that we are going to predict with the help of predictor variables or independent variables. So, the variables that are going to contribute in finding the target column are called as predictor variables. So, in this step of feature engineering, fifth step, feature engineering and selection, we are going to select the important features or important predictor variables that will be helpful in finding that target column. Using this step, we can improve the model's quality by creating, transforming, and selecting the most valuable features. We are going to improve the quality of the machine learning model that we are going to choose. For the example that we considered of predicting a house price, we can create a new feature like house age. It can be predicted using 2025 minus year build. I mean, the exact year that we are right now. We are going to use 2025 year and minus year build. Then we are going to combine bedrooms and bathrooms into total rooms. So it can create a total rooms column, which can be helpful in understanding how many rooms are there and how that total rooms are contributing in the target column, predicting the target column. Next, bin area can be converted into small, medium, and large. Then the next step of feature selection techniques. We can use statistical methods like ANOVA, correlation coefficient. We can use model based methods like feature importance in random forest, or we can remove irrelevant features like ID. So, based on the particular need, we are going to keep the columns, or we are going to create the columns, or we are going to remove the columns. These are the three important steps that we are going to do. If that column is important, we'll keep them. If it's not important, we'll remove them. If we want no new column to predict the target column, which will be helpful in making this process easier, we'll create a new column. And these steps are very important in making that machine learning model more efficient. After feature engineering, the sixth step is model selection. Now we are going to choose the right machine learning model by understanding how this data is working. So we can choose which machine learning model or which machine learning algorithm to use for this prediction task. So, candidate models for regression are linear regression, decision tree regression, random forest regression, XGBoost or gradient boosting, support vector machines. So, the approach that we are going to follow is we need to start with simple models like linear regression. As the data set is simple and easy for us to understand, so it says that even for machine learning model, the data set would be easier to understand because it has less number of columns. As the data set is less complicated, we are going to start with simple model called linear regression. Now, we need to compare the performance across other models using cross validation. The right model depends on your data complexity, interpretability needs, and runtime constraints. So, based on these situations, we are going to choose the right machine learning model by comparing their performance, accuracy, and their rates. After choosing the right machine learning model, now we need to train that machine learning model with 70% or 80% of data. We need to split the given data into 80-20 or 70-30 based on our need. So, in this training process, we need to feed training data, features and labels into the algorithm. The model learns patterns between input features and the target variable price. Using cross validation, we can use k-fold validation to avoid overfitting and get more reliable performance estimates. If a model is performing 100% accurate, that model is called as overfitting model when it comes to machine learning. Not like our exam marks. If we get 100, it is overfitting. It is not perfectly accurate. So, model training is where the learning process happens. Data turns into a predictive function. After choosing the right machine learning model and training that machine learning model, now the next step is model evaluation and tuning. So, this is the eighth step. After training, evaluate how well the model performs on unseen data. For this machine learning model that we have chosen as regression, so the metrics for evaluation is mean absolute error, root mean squared error, and R square score. For comparing the models and selecting the best performing model based on test set results, the next step that we need to do in evaluation is hyperparameter tuning. Using grid search CV or randomized search CV to tune parameters like max depth, n estimators, learning rate, these technical things, we need to do hyperparameter tuning. Evaluation ensures that your model is both accurate and generalizable for usage, and it will give you the accurate result more than you expect. Ninth step is model deployment. In this step, we are giving life to this machine learning model. Now you have a trained and validated model. To make it accessible for real world use, we are deploying it using API or application, using Flask, Fast API, or Streamlit to create a web application. You can host this application on Heroku, AWS, Render, or GCP. For example, if user enters the house feature, this machine learning model that we created as web application will predict the price of the house, and the result will be shown in the UI of this website. You can use deployment tools like Docker, GitHub, CI or CD pipelines for continuous delivery. You can deploy this model to transform your model into a usable product for the client. After deploying the machine learning model, the 10th and final step of ML workflow is model monitoring and maintenance. After deployment, monitoring the model is to ensure it continuously performs well. The reason why it is important is because market conditions and user behavior change over time. We call that as data drift technically. We can use monitoring tasks to monitor this model's performance. The tasks include tracking models' accuracy on new predictions. We can log user inputs and errors. We can trigger retraining when performance drops. We can additionally use retraining pipeline to maintain the performance of the model by scheduling periodical updates with new data. We can automate training and deployment using tools like Airflow and MLflow. The major reason for model monitoring and maintenance is a production ML system is never done. It needs regular tuning and updates all the time. I believe you got clarity about machine learning workflow from this video. If you want to know more about AI, data science, and machine learning, make sure you subscribe my channel so that you'll not miss a pop-up or any updates if I post a video.